In this section, we're going to cover confidence intervals for a population for the known or large sample size. In this basic graph, we first see that we have a mean of 10. Now, this is not a standard deviation. We're going to create a confidence level. We took a sample. We found the mean to be 10. We want to know what the population mean would be. And so when we create this confidence level, this book calls it an EBM. I'll discuss it in a minute. We find this EBM and we get an answer of 5. So we would add 5 to the mean and subtract 5 to the mean. Therefore, giving us this interval where the population mean might exist. To create this EBM, or what they refer to as an error-bound mean, we would take the z-score for our confidence level. So if it's a 90%, we look up 90% on the z-table. And we multiply that by the standard deviation divided by the square root of n of our sample size. And then we would add or subtract that to the mean that we found. So what I want to do here is to demonstrate this on the calculator and on StatCrunch. So on the calculator, we're going to understand that we have a sample size of 36 scores, so n will be 36. We find the sample mean to be 68. And this sample, the population standard deviation is 3 points. We're going to do a 90% confidence interval for this. So we go to our calculator and we go to our stat button. We go to the tab labeled tests and we scroll down to do a z interval. Now that's because we're doing the z tables, right? Enter. We're going to do it from the statistics we were just given. We don't have data for this. We know the standard deviation is 3. We know the mean is 68. We know the sample size, or n, is equal to 36. And we're going to calculate a 90% confidence interval. Now we calculate that, and we get the confidence interval is 67.178 to 68.822. We'll verify that. And we have 67.1775. They went a little bit further in depth than the calculator. And 68.8225. Let's try it with another one. Spring break can be a very expensive holiday. We have a sample size of 80 students. The average amount spent by students on travel and beverages is $593.84, and the sample standard deviation is approximately $369.34. And we're going to calculate a 92% confidence interval. So we'll go back to stat, go over to test. I can get to this not only through the down arrow, but just by clicking on the number 7. We know our standard deviation is off the screen here, 369.34. We know the mean is 593 and 84 cents. We sampled 80 students, and we're going to do a 92% confidence interval. And we will hit calculate. and we'll see 521.55 to 666 and 13 cents. And we see that we're just a little off on this one. And sometimes different people use different programs to calculate. And so sometimes you can be a bit off. All right, let's go back up to that first example again. And let's use StatCrunch. We'll go to Stat. We'll go to ZStats. It's one sample with summary information. The sample mean, we know it'll be 68. The standard deviation was 3. The sample size was 36. And we have to click confidence interval, and we're doing a 90% confidence interval. And compute, and we see 67.1775. This goes in a little bit more depth in the calculator, and we get the same answer that they had on the page. I can come back up here, options, edit, and I can recalculate things. If I need to change this, maybe I made a mistake and I want to adjust it, or I can start with a new problem. The sample mean for this second problem was 593.84. The standard deviation was 369.34. And the sample size was 80. And we're going to do a 92% confidence interval. And when we compute, we will see we get 521.54 and 666.13, which I believe is the same answer we got on the calculator, but not what the book has. But it's close. And if we have issues, I will adjust it.